Indices involving equations, case D, other cases. So in this video, we're going to look at other cases of indices involving equations that do not fall in line or do not fall into the category of simple linear equations, simultaneous linear equations, nor quadratic in nature. So these ones are just in a class of their own, but you just need to solve, or you also need to know how to solve them. Although most of them don't follow their principles of indices strictly, there are other things you need to do when you are calculating for x or the unknown value in these examples or exercises. Yet you're still going to apply the principles of indices or the laws of indices one way or the other for you to be able to get the final answer. Solution number 1. So given x raised to the power 1 over 2, x raised to 1 over 3 was 0.25 raised to 1 over 6. Find the value of x. 0.25 is equal to 25 over 100. So put this in place like this. So x raised to 1 over 3 is equal to 25 over 100, 1 over 6. Now x raised to 1 over 2 is equal to 5 over 10. 5 over 10 raised to the power 2, and then 1 over 6. So 2 times 1 will give us 2. X raised to 1 over 2 is equal to 5 over 10. 2 times 1 is equal to 2, 2 over 6. X raised to 1 over 2 is equal to 2. 2 here, 1, 2 here, 2. 5 over 10 raised to 1 over 3. Now, since we have same powers, we're going to create base. Since the powers are the same, equating bases, and x is equal to 5 over 10, which is 5 over 1, 5 over 2, 1 over 2, or 0.5. So therefore x equals to either 1 over 2 or 0.5. So that's the answer to number 1. Number 2, 2 raised to the power x plus 2x minus 1 equal to 48. Now we cannot write this in index notation because there's no number that 2 will be raised to give us 48. So we're going to come to this side, and what we do here is that we're going to factor 2x out. 2 raised to the power x is equal to 1 plus 2 minus 1 is equal to 48. 2 raised to the power x equal to 1 plus 1 over 2 is equal to 48. So we have here 2x. So this part here, 2x, 2 raised to x minus 1. Essentially that's 2 raised to x times 2 raised to minus 1. So by the time we factor out 2x, and here we also have 2 raised to the power x. When we factor 2x out, we will be left with 1 plus 2 raised to minus 1, which is what we have here. So now 2 raised to the power x, 1 plus 1 over 2. LCM is 2 plus 1. That's equal to 3 over 2. 3 over 2. That's 48. So I'm going to divide both sides by both sides by 3 over 2. So 2x here makes 3 over 2 over 3 over 2 is equal to 48 divided by 3 over 2. So this will cancel. not 2x, 2 raised to the power x. 2 raised to the power x equals to 48 times 2 over 3. 3 here 1, 2 here 16. So 2 raised to the power x is equal to 16 times 2 is 32. So 2 raised to the power x is equal to 2 raised to the power 5. So since the bases are the same, equating powers x is equal to 5. That's the final answer. Number 3, solve the equation 0.2 raised to x over 1 over 25. 0.2 is equal to 2 over 10, which is equal to 1 over 5. So 1 over 5 raised to the power x is equal to 1 over 25. So 1 over 5 raised to the power x is equal to 1 over 5 raised to the power 2. 1 over 5 raised to the power x is equal to 1 over 5 raised to the power 2. Since the square of 1 is also 1. So, okay, so let's also put it here. And it's square of 1 raised to the power 2, 5 raised to the power 2. 1 over 5 raised to x equals to 1 over 5 raised to the power 2. So since the bases are the same, equating powers x equal to 2. Or we can solve it this way. 0.2 raised to the power x plus 1 over 25, where 0.2 is equal to 1 over 5 raised to the power x equal to 1 over 25. So 5 raised to minus 1 x is equal to 25 raised to minus 1. So 5 raised to minus x minus 1 times x gives us minus x. 5 raised to minus x equals to 5 raised to the power 2 minus 1. 5 raised to minus x equals to 5 raised to minus 2. 2 times minus 1 is minus 2. So equating powers minus x equal to minus 2 and x equal to 2. Number 4, solve for x if 3x raised to 3 over 5 is equal to 81. So 3x 3 over 5 is equal to 81. So x raised to 3 over 5 is equal to 81 divided by 3. Divide both sides by 3. So x is 3 over 5 is equal to 27. X 3 over 5 is equal to 2 raised to the power 3. 3 raised to the power 3. So for us to be able to get the value of x here, we're going to raise both sides for the opposite of the power of x here. So to get the value of x, raise both sides to the opposite power of x. The opposite power of x. So x 3 over 5 raised to 5 over 3. So the opposite of 3 over 5 is 5 over 3 equals to 3 raised to the power 3 over 5 over 3 raised to 5 over 3. So here 3 over 5 3 over 5 times 5 over 3, 5 over 1, 5 over 3 and 3 over 1. So x is equal to, and here 3 times 5 over 3, 3 over 1, 3 over 1. So this is 3 raised to the power 5 and x equals to 3 raised to the power 5 will give us 3 times 3 times 3 times 3 times 3 1 2 3 4 5. This is 9. This is 9. 3. And 9 times 9 81 times 3. 3 times 1 3. 3 times 8 24. 2 4 3. And 5. 2x plus 3 raised to the power 2 is equal to 125. 2x plus 3 raised to 2 is equal to 5 raised to the power 3. Since the powers are the same, equating bases, we have 2x plus 2 is equal to 5. 2x equal to 5 minus 3. 2x equal to 2. And x is equal to 1. Plus 6. Find x if 5 x to the power 2 is equal to 1 over 25. To get x to the power 2, we need to eliminate 5 from here. So divide both sides by 5. Divide both sides by 5. So x to the power 2 equal to 1 over 25 times 5. And this will give us x raised to the power 2 equal to 1 over 125. Of course, this will give us x raised to the power 2 equal to 125 plus minus 1. Yeah, let me come over here. So x raised to the power 2 equals 125 raised to minus 1. And x raised to the power 2 equals to 1 over 125. X to the power 2 is equal to 1. 1 raised to the power 2 is equal to 1 divided by 5 raised to the power 2. X to the power 2 is equal to 1 over 5 all raised to the power 2. So since the powers are the same, equating bases x equal to 1 over 5. Number 7. Solve the equation 3x minus 1 plus power 2 is equal to 8 over 27. 3x plus minus 1 0 is equal to 2 raised to the power 2, 2 raised to the power 2, 3x minus 1 raised to the power 2, minus 1 raised to the power 2 is equal to 2 over 2 all raised to the power 2. So powers are the same, so we're going to equate the bases. Equating bases 3x minus 1 is equal to 2 over 2. So make it to the 1, then cross multiply, cross multiplying, this equals 3, 3x minus 1 equal to 2. 9x minus 3 is equal to 2. 9x equal to 2 plus 3. 9x equal to 5. Divide both sides by 9. Divide both sides by 9. We have here 9x over 9 is equal to 5 over 9. So x is equal to 5 over 9.